Maybe we shouldn't hide the... Nah, whatever. All right. Hi, guys. Thank you all for coming. This is more people than I think we expected. Cool. I'm Alex, and this is Alejo. We're both from Flashbots Research. This title is a little bit different from the title in the schedule. So we're going to talk about both MEV after 1559 and after the merge, so MEV and eth2. We'll run through both. We don't have a lot of time, but I think these are two key events that are happening in the next year or so in terms of milestones for Ethereum, and so it's important to think about MEV in that context. Structure. Okay, I'm just going to do this. All right. Very basic structure. I think first we'll just introduce what MEV is and give explanation around that. I don't think, well, it's good to remind ourselves of that. And then Alejo will talk about the research that he published yesterday on the topic. Yeah, and then I'll talk about MEV after the merge, and then in the end we'll talk about Flashbots and what we do, and I guess how that relates to MEV. All good?
All right, thank you, Alex.
I think you can use this.
Okay, we'll try that. Thank you, Alex. Thanks, everybody, for being here. I will, so MEV is a hot topic these days, but I will not assume that all of you have heard of it, so I'm going to try to give a brief introduction to the phenomenon. So this is a sort of a fairy tale day in the Ethereum blockchain, where we have trades going on, arbitrage, liquidations, and all of these are good, right? Arbitrages are good for keeping prices sensible, right? The prices are the same in different dexes. Liquidations help with the different protocols, lending protocols have money in them and not go bankrupt. So all this is like a happy path, and it would be very nice and clean if Ethereum was just that. But we know it's not just that. So once we come closer to it, we see we come to the dark forest. This is a metaphor that has been used recently. Probably most of you heard about it. And this is an alternative name for the Ethereum mempool. So what goes on in the Ethereum mempool? So say there's this bot here that sees an opportunity, a price difference between two decentralized exchanges, and says, okay, I want to buy in one and sell in the other to make a profit. And so the miner comes along and wants to include that. I might be missing some. Okay, I'm missing a little bit of the. But then other bots come along and say, okay, no, hey, I'm also want to do that arbitrage, perhaps because they saw the same opportunity, or perhaps because they saw this first bot trying to take that value that was just lying there, and okay, so the miner comes and says, okay, this bot is paying me something to include their transaction, this other bot is paying me more, so what will I do? Okay, so the miner sees this picture and says, okay, I'm going to first pick this one because it's the one that pays me more. And then, why not, I will also include these transactions, even if they will probably revert, because the operator traders there are trying to make sure that they are going to make some profit by doing this. So if the opportunity is gone, there's no profit, so this is gas that it's burned. So this, of course, is bad. These are called priority gas auctions, because the one that pays the most gas gets in, right? But it leads to a lot of gas burn, increased gas prices, right? This is bad for users because it artificially increases the gas price. It also blows the chain, right? Because we get all these reverted transactions that are meaningless. They could have been avoided, right? And so on. So this is one example. Again, some people are capturing some value here, but this is a very inefficient process. Another example here, there's an Oracle update. So as I said before, there's some opportunity for liquidation in lending protocols. Sometimes prices change, and then some positions become unhealthy. And so the miner, I'm missing some of the things there, but these are all, say, paying the same money. So the miner has to choose at random which one they include. So perhaps they pick this one, but this liquidation doesn't go through because the Oracle update is still not in. Then they randomly pick the update, which pays the same thing. And then now that the price update is been included, there's another liquidation that does go in because now the price is the new one, and then another liquidation that doesn't work because the position was already liquidated. So all of these are included in the block. Some of these revert, again, bloating the chain. And this is called backrunning. again, leads to a lot of unnecessary negative externalities for the network. And again, sorry I'm missing some of the things here. We had some issues with the animations, so thanks Alex for putting this together. It was like Google Slides. All right, so it's actually more complicated than what I described. This is like still already a happy path, but say like the miner comes and sees this picture where there's an arbitrage bot offering to pay a lot, and then liquidation, like also happening there with an update. So the miner might actually say, okay, like why would I let all these bots take all this value if in the end it's me who decides which transactions to include in the block, right? So I can say, okay, I'm going to make the arbitrage myself. I'm going to like benefit from this difference in prices in the dexes. I'm going to buy here, sell here, and include the arb. Then I will include the Oracle update because I need that to liquidate, and I'm going to do the liquidation myself. And I don't care about these bots, right? Because in the end, like, I can do whatever I want. I'm the miner. I decide what comes in the block. I can also, as a miner, include these other transactions, and again, now will revert because the opportunities are no longer there because the miner took them. So again, this more bloating and the miner taking the most out of this. That's why we come to the definition of like maximal extractable value, formerly minor extractable value, because again, it's the block proposers, typically the miners in today's proof of work Ethereum, who have the ultimate decision power on what gets in the chain, what gets mined, right? So the minor extractable value or maximum extractable value is the value that can be permissionlessly extracted from the blockchain, right? So anybody can extract it. Miners nowadays are the ones that, because they are the ones who decide what gets in the block, are the ones that can actually extract this value if they want it, right? And okay, this is already a fairly bad picture, again, because of all the inefficiencies I was telling you about, bloating of the chain and so on, and inflated gas prices, but it can get even worse. So say there's a situation where we have like the chain with a block with a lot of value in there. Again, perhaps there was a huge liquidation, right? And for you to have an idea of the values here, we're talking hundreds of ETH, perhaps. We've seen liquidations of 100 ETH, 300 ETH, I think was our record one. So it's a lot of money there. So the miner comes along, and the standard behavior would be to mine on that block, right? This is what we expect miners to do, to keep extending the longest chain. But they can also say, okay, no, wait, if there's all this money, I would rather mine on an earlier block, right? And like capture all that value myself. And I can even leave some money on the table for the next miner to come along to be incentivized to mine on my fork of the chain as opposed to the longest one. And they could even rent GPU power specifically to get this action going, right? So this is problematic, of course, because it could threat consensus, right? There could be like a race between miners to try to rewind the chain and see who gets all this value that's up there. So these are called time bandit attacks based on chain reorgs, and again, this all lead to an impending MEV crisis, right? If this was a common practice, it would be super problematic for the network, and the more MEV there is, the larger the chance that this happens, right? Because the larger the incentive for miners to rewind. So anyway, this minor extractable value has been a prevalent phenomenon, the extraction of it recently, and it's something we need to pay attention to and be very careful with if we want to keep Ethereum alive, right? So anyway, this is like an introduction to MEV. These are some numbers, and I see already some from the team cringe for me using this slide. This is from our Explorer. All these numbers are, take them with like a grain of salt, because these are, they vary a lot and they're very hard to estimate. This is the Explorer, we have Flashbots, you can check in that side. And it's tricky, I think it gives a solid order of magnitude of the numbers, but again, take the specific numbers with a grain of salt. It's very tricky to get these numbers right. So we have to go through all the protocols and check what actual value is being extracted. But this is a good order of magnitude. This year, almost $800 million, $400,000 in 24 hours. This is the amount of value that's being extracted by searchers, bot operators, and so on. Good. So after that like quick intro to MEV, we can talk a little bit about what's the future for MEV. So that sort of reflects what's the situation today. So I'm going to talk a little about EIP 1559 coming in 2 weeks now, so pretty soon. And then Alex will tell you about MEV and the merge. Okay, so what I'm going to tell you about, some of what I'm going to tell you about and some more, you can check in this post we published yesterday from Flashos Research. It's a post in collaboration with Christoph Gasso from Nethermind, who's here in the audience. So you want to check it out. It has other things. I'm going to just talk a little about some of the conclusions there. So, and I have to introduce very briefly what 1559 is and the changes to the price mechanism, to the fee mechanism, in case not everybody is familiar with that. So current Ethereum is essentially the user submit transactions with certain gas prices. After 1559, it gets more complicated, right? So users will have to set a priority fee and a max fee. And the protocol itself sets a base fee. The base fee is set in a way that so to compensate for the protocol's usage, right? So if the network is loaded and the blocks are more than target full, the base fee will go up, and if the blocks are under full, like to the target block size, the base fee will go down. So again, users set priority and a max fee, and what they ultimately pay is the minimum between the base fee plus the priority fee and the max fee. The max fee serves as a bound in case the base fee goes up suddenly, so they don't have to pay an expected price, an unexpected price. Okay, so this is how 1559 works, and to our question, like how MEV changes after 1559, the answer is not much. So the 1559 thing will hopefully improve UX, apart from the burning of ETH, but there's no new MEV. And I put an asterisk there because there are some like very border cases, like there's now there will be more eviction of transactions. So if transactions pay a fee that's very low for the current base fee, they get cleaned from the mempool, so they get dropped. But a sniper could be there checking those transactions and storing them for later use. And if the base fee later goes down, they could replay those transactions and extract MEV from them if there was any, right? So, but again, this is like a very, but generally no new big MEV opportunities. But still, there's something to be said about 1559 and MEV, and I will talk a little bit about that now. So the main point here, I guess, is that EIP 1559 was designed, and also most analysis around it, around the incentives in it, were done in a pre-MEV world. Not that there was no MEV, so MEV was there all along, and there was even like some capturing or extraction of that MEV, but not to the extent that it is prevalent today, right? So this design and analysis assume an auction for transaction inclusion, where users in Ethereum, what they want is to get their transactions included, and just that. Nowadays, we know that the picture is very different from that, because users are bidding for other things in Ethereum. They're in particular bidding for ordering of transactions, bidding for privacy. For instance, if you don't want to get your transaction front run, you might want to use like a service like Flashbots for obscuring your transaction to the rest of the network, and so on. So the picture is much more complex than the naive assumption of an inclusion auction might lead us to believe, right? And so what does this mean? So if you look, for instance, at Tim Roughgarden's analysis of just a really good paper analyzing the incentives around 1559 and how the system will work, and how Ethereum will work after the London fork. So he defines 3 things that would be desirable from a perspective like short-term, one block type of horizon. And the first one is myopic miner incentive compatible, meaning that miners are incentivized to work according to the mechanism. The second is user incentive compatible. This means that users are incentivized to bid their true value for their transactions, and this is what doesn't happen today in Ethereum, because you have to be strategic, right? You have to look at the gas price, you have to think, okay, if I want my transaction included, I want to pay as much, but not, so you're calculating all the time. This is what 1559 aims to solve, right? So you don't have to think out what everybody else is doing for submitting your transaction. And finally, off-chain agreement proof, meaning that miners and searchers are, miners and users, sorry, are not incentivized to make like off-chain agreements and side payments for miners to include their transactions, right? So what he shows in the paper is that EIP 159 is MMIC, is OCA proof, and it's UIC only outside periods of high demand, right? So the UX improvement we expect to have outside of periods of rapid demand hikes, right? And we can live with that, it's okay. And it's again I don't know, a compromise we accept. Interestingly, in the same paper, he considers an alternative proposal. So this is not 1559, but it's something we could have done alternatively, which is the tipless mechanism, so no priority fee. He shows in that paper that tipless is MMIC, is UIC, and it's only OCA proof, only outside periods of high demand. So it's a trade-off, right? We could have gone tipless, and then we would have the UX improvement always, but would not have the OCA proof. And that's okay. It's fair that we chose 1559. But the thing is, in the pre-MEV world, we didn't have these OCA agreements, these off-chain agreements. Now, with systems like Flashbots, that we're going to talk about a little bit towards the end of the talk, we do have these OCA agreements all the time. All the time, like searchers are, we were running an auction for searchers trying to capture MEV, that they're trying to order the transaction in a specific way, and they're telling miners, hey, if you order these transactions in this way, then you'll get some of this, some payment. And so all this auction that we know Flashbots and other systems out there actually are OCAs, right? So right now we're running separate auctions at the same time, and we have OCA. So we might think, okay, perhaps we could have worked with a tipless mechanism and preserve this UIC, these UX improvements for users that are only concerned with transaction inclusion, and have that all the time, and then run a parallel auction like Flashbots for transaction ordering, right? So the takeaways here is like, okay, if we think of MEV, perhaps the considerations for design at the base layer are somewhat different. And to wrap up this thing, right now, again, I talked about inclusion, privacy, ordering. These things are being auctioned in different parts of the blockchain, some in the protocol level, right, and some like Flashbots or other relays or dark pools, right? So this just one side point here. If you look at traditional finance markets, like the different instruments are, they have their own markets. If you look at options, they have one market, and if you look at I don't know, stocks, they have different market because the instruments have different properties. So in order to get an efficient market for each, you need different designs for each one. So so this says, okay, we have all these auctions that are auctioning different goods, and this is a very haphazard process with how we build different auctions. So one big problem at Flashbots we're trying to do research on is to what extent we can have like a universal auction to express all these complex things that someone would eventually want from a blockchain, right? And this, again, is one of our main research problems, and if anybody is interested, welcome to come and work with us on these very hard problems, right? So anyway, the takeaway here is that now that MEV is commonplace, we need earlier involvement with the EIP process, because some of these things are super relevant at the base layer and perhaps could be better solved at that layer. So in particular, with Ethereum 2, now we have bonds with the validators and so on. So that's very, has a lot of impact for MEV. So perhaps some of these things can be solved at the base layer. And now Alex will tell you about that and how MEV interplays with Ethereum 2. Wait, it's not done yet.
All right. Thank you, Alejo. That was great. Also, I could see how like my face. Cool. All right. So just like Alejo was talking about some of his research, this is some of the research we did on eth2. There's a post on HackMD, and there's also a repository for some of the modeling we did that's relevant that I'm going to talk about. So first, I'll talk briefly about the merge. I assume that you guys are familiar with it. We're at the Ethereum Community Conference, but still, right? So the merge essentially is merging the beacon chain with the current Ethereum 1 chain, and Ethereum moving from a proof of work to proof of stake consensus protocol. And so why this has already started here, right? Yes. Why this has already started here is because the Beacon chain was launched in December 2020 and has already accrued validators that are depositing security deposits of 32 ETH. And so what essentially happens at the merge, which will happen sometime in the future, is you're changing the consensus engine of Ethereum from the proof of work engine to a proof of stake engine. Kind of mid-air, right? Which is why that image was very fitting. Not as risky as you would imagine, just because the Beacon chain is already launched, and as it accrues more validators, the security of Beacon chain supported consensus is just better. And so by saying this, what essentially happens, or what eth2 ends up looking like, is this kind of two chains in a way that advance in lockstep. So you still have the existing Ethereum chain that's stripped of its consensus power, and then you have the Beacon chain. And so the Beacon chain has Beacon blocks, and the Ethereum chain still has eth1 blocks, right? And so in each Beacon block, you have a few objects in it. Some of them are consensus objects, like votes from people that are part of the Beacon chain, so from validators, the testers or the Beacon block proposers, but you also have the eth1 block in there that's added. And so that's how the eth1 block with the transactions as you know them today would be validated by the consensus, the proof of stake consensus. And so, because again, this dual chain setup, the eth2 client that might be run by validators or generally the Ethereum client looks like this kind of like this dual component client, where one part of the client is the Beacon client that validates Beacon blocks and forms them, and then does a bunch of other consensus roles, and then the eth1 client that assembles the eth1 blocks. And so why that's important and why I put this here. So this is not necessarily it, but this was shared a lot in the Ethereum community, is because the person running these clients, I mean, there could be two different entities running these clients. So the person running the eth1 client can be different from the person running the Beacon client. This is going to be relevant to what we'll talk about after. And so let's go briefly through transaction execution, kind of, or submission before the merge and after the merge. So today, users send their transaction is propagated through the eth1 P2P layer. Transaction shows up in different client mempools. So miners will maintain an eth1 client. Each client has its own mempool, and so as they receive their transactions propagated through the P2P network, they have that in their mempool, and they pick transactions from it. The eth1 client forms the block, and the block is added to the eth1 chain if the proof of work lottery is won, and then that's how the blockchain moves forward. After the merge, the user still sends a transaction. The transaction is still propagated through the same P2P layer, which is def P2P. The transaction then shows up in eth1 client mempool just as well. The eth1 client still forms the block. The only difference, as a kind of you saw in the previous slide, right, is that the block is past the Beacon client, and the block is included in the Beacon block, and then as the Beacon block gets voted on by validators, testers in that case, it kind of gets reflected back to the eth1 chain. All right, so why am I kind of summing up all of this is just to kind of make the point that transaction ordering, as we know it today, still exists in eth2. So the MEV that Alejo talked about, the one related to arbitrages and liquidations, will still very much exist in that world, right? Nothing changes at that level of how not only the P2P layer where transactions are propagated, but also the software that orders these transactions. So software like Geth or like Open Ethereum, I guess, before. So let's talk about MEV and how MEV is affected by that. I'm only going to cover two broad points, and then because I've given a version of this talk before, I want to focus more on some of the open questions and things that might be interesting to you guys if you've followed any talk before. If not, all right, so technical change. One thing that happens in eth2 is there's a strong decrease in the rate of issuance of Ethereum and proof of stake Ethereum. So what that means concretely, the reason for that is there's no more block reward or uncle reward. So you don't have that 2 ETH block reward for every block for miners, and you don't have uncle rewards as well because you don't really have uncles, at least in the same way. And so why that's particularly relevant is because from the previous slide, what I mentioned that MEV as it exists today will still exist in eth2 and will have the same size, which, like, Alejo mentioned that 700 million figure. And so relative to the rewards that a validator or a block proposer would get, MEV will be a larger share of that than it is in eth1. Yeah, and this is from a post from a testant, sorry. Great, you should check out the post. Sorry, maybe if I want to comment on this. These are different phases of issuance of Ethereum. So this is Ethereum 2 phase 0, which is when the beacon chain was launched. So there's more issuance there, right? Because now Ethereum issues rewards to validators on the beacon chain as well. So it's slightly more. EIP 1559 is put here. And I guess there's not a lot of impact to issuance at that point, but that grows with transaction volume. And then the end of mining here, this is really like the merge and boom, that happens. And so that's not exactly it, because actually issuance in ETH2 grows proportionally to the number of validators, but it's still a lot less than in proof of work. That's one of the key advantages of proof of stake. And so why that's interesting, because the share that MEV represents is going to be higher. And we didn't really cover this a lot, but MEV is also a reward that the block proposer gets. And that's something that Flashbots kind of enables, that Alejo talked about as the ultimate actor that includes those transactions can either front-run the people that submit those transactions or submit them themselves. And so what is meant by this, what I'm trying to get at with all of this, is just that MEV is a bigger deal in ETH2 because it represents a larger share of the reward that someone who's part of the consensus protocol is going to get. So we ran some numbers on this, and at the current level of validators, so that has changed now, but right now it's about 195,000. So I put 200K. MEV can increase validator rewards relative to the base rewards that you get from the protocol by 67%, which is a considerable amount. And so I guess what's important about this is MEV extraction will be much more desirable in ETH2, and people will seek it a lot more. And they'll have a much bigger reason to do so just because of its impact that it has on the revenue of the block proposers or consensus actors, in that case, the validators. That's the first point that I think is important to remember. So when you think of MEV today and how, I guess, aggressive or how competitive the landscape is, when you move to ETH2, things are going to get, I think, a lot more intense. All right, second point. A political change that impacts MEV is that miners are replaced by validators. So I'm not, you guys are all aware of this, but who are going to be the biggest validators? They're going to be the largest ETH holders. And who are the largest ETH holders? Exchanges. So you can see here already, this is taken from beaconcha.in. And you can see already Kraken is in there as like a nice 19% chunk, and then Binance is in there. You can't see Coinbase, but Coinbase is definitely in there as well. And so that's kind of interesting that exchanges are going to have that much power relative to miners and mining pools, because exchanges have other businesses. If you compare it to mining pools' sole business is usually to host this mining services for other miners and distribute rewards, and then maybe they have some kind of like staking service on top, or they do some trading on the side, but their main business is kind of mining. An exchange provides, of course, exchange services, and in the case of like Kraken or Binance, they also provide usually custody services and that type of stuff. And so what's interesting that might happen as a like dynamic is that the largest exchange can provide this kind of like full stack MEV service. So they own transaction flow from the users. They have the capacity to extract that MEV themselves, and they also own a large chunk of transaction ordering, because here, when this says like Kraken 20%, this means that in 20% of the blocks, Kraken has the ordering. It's not exactly that, but and so that's kind of worrying in some sense, because right now the roles are separate, and I think that there's some equilibrium in that market. And when you have players that have that much power, it can really encroach their dominion over the space. And I think it's something that we all, I don't know if we want to avoid, but at least we want to be mindful of before we kind of set those dynamics, and then it's very hard to change. Second thing related to that is the other largest actors are going to be Metapools. So pools of pools, like Lighto, that's mentioned here, although that chunk is definitely wrong. but doesn't matter. So Lighto is a pool that connects to other pools and offers on top of the kind of staking service they offer also staking derivatives. One thing that's interesting is Ethereum is currently locked, so when you stake it, the withdrawals haven't been activated yet, right? But so what Lighto offers, as one of the product they offers liquid staked ETH. And so you're able to use the ETH that's staked and that's still locked in the rest of the, I guess, DeFi and Ethereum ecosystem. And so now if you imagine that MEV rewards kind of flow back to that token, you now have potentially some kind of DeFi ecosystem that springs up of MEV-based DeFi products, especially thinking about like future cash flows related to MEV. And so that can be really interesting. And again, it's something that's much more advanced than what we've seen today, but it sounds, or at least it seems like this is a very natural direction and something that people have been talking about. There's someone who posted something on Twitter yesterday, I think Julian Traversa, along those lines. I think people have been thinking more and more about MEV cash flows as well. And so that's interesting. I talk more about all this in the post and a lot more about our numbers as well. I barely covered that. Oh yeah, this is the liquid thing from Lighto. All right. Cool. All right. So I want to more focus on like the open questions and for research real quick, because these are the cool things in my eyes. So one thing that I didn't talk about is that MEV can increase the inequality between validators. So one of the good things with eth2, at least initially, is that relative to eth1, about 7-8% of the rewards that you would get as a validator, so compare validators to miners, is just for good behavior of like submitting attestations on time. Whereas on eth1, you would get most of the reward by being a block proposer. So whenever you propose a block, you get that huge 2 ETH chunk. But so what happens with MEV is because MEV's distribution differs per block, whoever proposes a particular block might get a lot of MEV reward from it. And so that might amplify inequalities between validators, because whoever is lucky enough to propose a particular block that has a lot of MEV is going to get a lot of rewards. So if you think back to the pie charts that I mentioned before, maybe some of the largest players are going to have outsized luck compared to others, and so they're going to be able to even spin up more validators and stake even more 32 ETH security deposits, and then that you get into this kind of rich get richer dynamics, or this Matthew effect. So it's something we want to research more because it's not as obvious as the intuition that I just gave. And so it says FRP 15 here because it's one of, I guess, our research proposals that we're working on. And several people here are working on it. I think Alon might be in the room somewhere. There you go. Alon from Block Staking, and then Barnabé and Casper from the Ethereum Foundation, from the Robust Incentives Group. And Barnabé already did some modeling of this. That's the first link here. And found some interesting results, actually, that are counterintuitive. I won't go into them now, but that's one kind of open question that I think what we're worried about is that MEV in eth2, because it's a bigger deal from what I mentioned before, actually creates strong inequalities that are unwanted. Another thing that we're looking into, and that's part of the same research kind of track, is the vectors of attacks that are spawned by MEV in eth2. So Alejo mentioned block reorgs or time bandit attacks, so we're trying to understand how does that look in eth2. What are other attacks that someone might do? One thing that could be mentioned, for example, is because in eth2 you know who proposes the block in advance, so one epoch in advance. You could, for example, find that validator in particular, and there's more kind of room for collusion given that you know them in advance, and so there's stuff there. The third kind of open research question is on the block proposer builder market separation. So if you remember early on, I talked about how the eth2 client, that kind of dual client, it can be two entities running them, or two separate entities running them. And so Vitalik actually wrote an eth2search post about that a few weeks ago after we kind of brainstormed with him, and it's actually applicable to other things, where he envisioned a market where the eth1 node runner assembles the best block that they can, and they submit that to the beacon client. And that also has applications for how shards are submitted to the beacon block. Shard blocks are submitted to the beacon chain. That's very interesting. That's more of like a crypto economic open question of how you would design this. In the case of eth2 is how do you design against malicious validators? Are there kind of any opt-in slashing mechanisms? Can you piggyback off security deposits, et cetera, et cetera? That's also very interesting, and that's FRP. That's the kind of 14. And then the last thing is thinking about alternative designs for MEV mechanisms, given the new constraints of this system. And that's something that Thomas from Nethermind and Flashbots and Euler is going to talk about later today. Not in this room, but I think in the main room. And he's going to present kind of alternative designs for what a system like Flashbots might look like. And so again, thinking about what I mentioned before about block proposers being known in advance, there's interesting things that you can do with that. And so that's one of the designs that we have. And then we also participate in this hackathon with Lighto and Nethermind. And we kind of built a proof of concept of this kind of dual client model, but that's enabled for MEV. So that's it in terms of a few open questions. And for research, all of those are public on GitHub, and anyone can participate in research. They're already kind of on their way a little bit, so right now might not be the right time, but generally we always have our open research tracks there, and we have contributors that are working with us, and then we write together and kind of work together. It's nice. Yeah, so I'll pass it back to Alejo to just talk about Flashbots a little bit, and then we can take questions. I think we'll have a bunch of time for that.
I don't think so.
Oh, you don't
think
so?
4 more minutes, moderator.
Oh.
Can we do questions offline and complete this? 4 minutes? Okay, thanks. Yeah. So yeah, I want to say a couple of words about Flashbots, the organization, because we have mentioned that in passing, but perhaps it's unclear. So Flashbots is a it's a research and development organization working on mitigating the negative externalities of MEV extraction. So our goals are up there: illuminate the dark forest, democratize MEV extraction, and distribute benefits. So what we want is essentially so we believe MEV is essentially unavoidable in stateful blockchains. So the idea is to minimize the negative externalities that its extraction has for the rest of the participants in the network, right? And we have several areas. One is the auction, this thing made more efficient for extraction, so that, again, we don't have these races I was mentioning before. We have a data part where we collect some measures on MEV, which I showed before also, and the research side, Alex talked a little bit about the FRPs. We have grants, so if you're interested in this, please come talk to us. Or you can check our Flashbots.net GitHub. I want to say just a couple of words on Flashbots ethics. So right now, 85% of the miners are running our software. We have, as part of the auction, a fork of Geth called MEV Geth, which essentially is a new shelling point, right, for the network, because we could push an update to miners that they could passively adopt and collude by just passively adopting a software update, right? So as an organization, we have to think about this and think about the consequences of this, because again, we don't want to harm the network. We want to be super careful and transparent about this. So ethics is a very important point for us. So this question I was saying before, can we help miners collude, and to what extent? For instance, one other question we tackle in the post I mentioned is, can Flashbots defeat the purpose of 1559? We did some data analysis here. Can we propose a mechanism whereby we could keep the base fee low, and it's unclear whether this will be good for miners in the midterm. Anyway, I encourage you to check the post for more on this. And finally, I wanted to touch upon one question that was making the rounds recently, where we would support reorg. So we make MEV extraction more efficient with these bundles where users can bid for transaction ordered sets of transactions essentially. So there was a question, will we support this time bandit thing where we make it easier for miners to rewind the chain upon request and payment? So the answer is no, and I encourage you to read that post we posted last week on this. We believe reorgs are negative for the network, again, because what I talk about, threatening consensus and making finality impossible. So we are not building a client that does this. We think it's a thing that's important to be researched, and we have to pay attention, but it's something we ultimately don't really want in the network. So I wanted to clarify this point. So yeah, I think with this, yes, we are done. So thank you so much. Sorry about not leaving time for questions, I think, but we are here, Alex and me, so if anybody has questions, we're happy to take them offline.